Hello there, it's Justus, your maths and statistics tutor. In this lesson, I want us to learn about equations of perpendicular lines. But before we start solving problems relating to equations of perpendicular lines, can we first understand what are perpendicular lines? So, in this our interactive graph, I want to plot two lines. Can plot the first line like that, and then also plot the second line like that. And as you can see, these two lines intersect at a certain point. And in our case, that point is 0, 0. So they intersect at point 0, 0. And however much I extrapolate these lines, the point of intersection doesn't change. So, in simple terms, perpendicular lines are lines that intersect at a certain point, and that point is fixed. It doesn't change, however much you extrapolate the lines. And actually, that is the first characteristics of perpendicular lines. But now that we know perpendicular lines have a fixed point of intersection, we can also study the behavior of their gradient and also maybe the behavior of their y-intercept. Can we start with the gradient? So, to understand about the gradient of these lines, I can call the red line as line 1 and the blue one as line 2. So, I need to pick 2 points from each line so that I can calculate the gradient. If you don't know how to calculate the gradient of the line, you can review my lesson 2 and lesson 1. You'll understand how to calculate gradient of a straight line. So, here, can I start with this red line, where I can pick just random points. But in my case, I can pick 0.4 and 8. So the first point is 4, 8. For that line, I can just pick it as 4, 8. And I can pick another point just below that. I can say point -2 and -4. So I can pick point -2 and -4. And then when I come to the blue line, I can also pick random points, like can pick point 8 and point -4. So I have point 8 and point -4. And I can also pick another random point like point -4 and point 2. So point -4 and point -2. Is it point -2 or point 2? I picked point -4 and point 2, not -2. So this one is 2, not -2. Let me write it again here as point -4, 2, and b as point 8, -4. I can cancel this one here. So, if I want the gradient of line 1, I can say it is m1 is equals to change in y all over change in x, which is the same as y2 minus y1 divided by x2 minus x1, which is the same as, you see, I already have all these points here. So in this case, this is x1, this is y1, this is x2, and this is y2. So I just need to replace them here. So y2 is 8 minus y1 is -4, then divided by x2 is 4, then minus x1, which is -2, and the answer becomes 8 minus -4 is 8 plus 4, which is 12, divided by 4 minus 2 is 6. So it becomes 12 divided by 6 is 2. So the gradient of the first line is 2. How about the gradient of the second line, which I can just name is M2 is equals, the formula is the same, so I just need to replace the points. So that's point, this is point x1, this is point y1, this is point x2, and this point y2. So I start with y2, which is -4, minus, what is y1? y1 is 2 divided by x1, which x2, which is 8, minus -4, which is x1. So it becomes -4 minus 2 is 6, and divided by 8 minus 4 is 12. So it becomes, this is -6, so it becomes -1/2. So that is the gradient of the second line. So M2 is -half. So do you realize the gradient of line 1 is 2, the gradient of line 2 is -half? Kind of like the gradient of line 1, that of line 2 is kind of like the reciprocal of the gradient of line 1, but now with a negative sign. So this property of perpendicular lines, we say the product of the gradient of line 1 multiplied by the gradient of line 2 should be equal to -1. So can we try this? The gradient of line 1 is 2, and the gradient of line 2 is -half. So their product is, if I divide this one by 2 by 2, it becomes -1. So that's a property of perpendicular lines. The product of their gradient should total to -1. So if I give you a line which has a gradient of, for example, 2, and I tell you it is perpendicular to another line, you should automatically know that that other line, its gradient is the reciprocal of that first line, which is a half, but now we put a negative like that. So with that knowledge, can we try to solve questions relating to these perpendicular lines? So let's try this question 1, where it says find the equation of a line perpendicular to line y is equals to 3x plus 2, and that line passes through a point. I can call that point like point here for that other line, which is 2, 5. But we already know perpendicular lines have the product of their gradient should total to -1. The fact that I have this equation of the first line, I can equate it to the general formula of the equation of a straight line, which is given by y is equals to mx plus c, where m represents the gradient. So in our case, then this m is 3. So m1 is 3. The gradient of this line is 3. So the gradient of line 2, which now will be this one, should be the reciprocal of this one, but now with a negative. So that the moment I multiply these two gradients, 3 by -1/3, the product will be -1, like that. So now that I know the gradient of this line, I can calculate the equation of that line. And in this case, I can say this is x1 and this is y1. If you don't know why I'm labeling these values as x1 and y1, you can review my lesson 3 and lesson 2. You'll understand the logic of calculating gradient and also labeling these coordinates of a line. So now that I have x1 and y1, I can apply this formula. Y minus y1 is equals to m, which is the gradient of that line, into x minus x minus x1. So it becomes y minus y1, because I have it is 5, is equals to m, which is negative 1 over 3, into x minus x1, which is 2. So becomes y is equals to negative 1 over 3x plus, because this negative multiplied by negative will be positive, plus 2 over 3. But don't forget we had a 5 here, so if I take it on the other side, it becomes plus 5. So the answer becomes y is equals to negative 1 over 3 plus, if I take 2 over 3 plus 5, 2 over 3 plus 5, I can just put it like over 1, then I say the reciprocal, the LCM is 3, then 3 by this 1, 2, then plus 3 by 1 is 3, then by 5 is 15, so it becomes 2 plus 15, which is 17 over 3. So I can just say it is negative 1 over 3 x plus 17 over 3. So you see, these two lines, this one has a reciprocal, as a gradient of negative 1 over 3, and this one has a gradient of 3, such that when you multiply the gradient of this one with this one, you'll get the resources negative 1. Can we try another example? We're going to give a line like y is equals to negative 2x plus 4, and then another line passes through point A, which is 1, negative 3. Then from there we can get the gradient of this line, m1, should be equal to negative 2. I got it from here. Then the gradient of this other one, of course, should be such that when I take m1 by m2, the answer should be equal to negative 1. So to get that, since I already have the first one, I'll say negative 2 multiplied by m2 should give me negative 1. So, and then m2 should be something like a half, such that when I take negative 2 multiplied by a half, the answer is negative 1. So the gradient of the second line is half. Then now that I know the gradient of the second line is half, I can label these values as x1 and y1, and then I apply my normal formula where I say y minus y1 is equals to m, which is the gradient, into x minus x1. Then I say y minus y1, y1 here, which is negative 3, negative 3 is equals to m, which is half, into x minus x1, which is 1. So it becomes y plus 3 is equals to half x minus half. It becomes y is equals to half x minus half plus 3. Minus 3, sorry. Minus 3, because I took that 3 on the other side. So minus half minus 3 becomes, it's kind of like saying this, y is equals to half x minus 3 and a half. 3 and a half, which is the same as saying y is equals to a half x minus 5. Oh, 2 by 3 is 6. 6 plus 1 is 7. So minus 7 over 2. And that becomes the equation of the line. And as you can see, it has a gradient of half, and the other one has a gradient of negative 2, such that when we multiply both those gradients, the product will be negative 1. So, can you try question 3, and we can meet in the next lesson. Bye for now.